How's it going, YouTube? Welcome to the fourth episode of building your own custom 3D playground. We're going to use OpenGL, GLFW3, Visual Studio to do so. And being that this is the fourth episode, we're a little further in. Now, if you haven't watched the previous three, well, I guess I don't blame you. But mostly what I go through in those is how to build libraries and how to attach the libraries you need to Visual Studio. So being that it's been a while, I'm going to go ahead and take it right from the beginning and go from kind of the nothing state all the way to rendering some stuff on the screen. If you want to do this in a game engine like Unreal or Unity, this might give some background info as to how they may do some of their things in those engines already, but really this is its own standalone thing and not related to those game engines. All right, let's get into it. So first you need Visual Studio, of course. I'm using Visual Studio Community 2019. You can get this for free. If you don't have it already, just find it through a Google search. You'll get a Visual Studio installer, and with that you can pick which version you have installed. You can modify and launch. So just real quick, I want to hit modify here to show you what I got. I just have the really basic stuff, the core desktop features, and I have this stuff too. I'm not sure if I even need any of this other stuff, so I'll just scroll through it just in case anybody needs to see it. Okay, so let's make a new project, and we're going to make it empty C++. That's fine. Okay, let's go. And we're going to name this 3D Playground Vid 4. So that's a very specific name, I realize, but keep it organized. And now that we're in here, I'm going to go ahead and change the file view to show all files. That way we can see everything in our project. And as you can see here, there is nothing in our project. It is completely blank. So we're going to add a few folders. First, we're going to start with a new folder, and we're just going to name this one SRC for source code. And I think that's all we're really going to need. No, we'll need a few more. I'm going to add include, and I'm going to add library. So just keep adding new folders here, because this is how we're going to include and link GLFW3, which is our windowing system, and we'll add more things later as we need them for like math and stuff. But OpenGL should already be all set up with your video card. Okay, so source. Let's add a source file. We just want a new item here, and we'll do it a CPP file. I'm just going to call this main.cpp. So Visual Studio handles all your setup for, well, it handles all the build setup. That's one of the things that's nice about it. You don't have to manually configure things with a makefile or something. It just kind of sorts that out for you, so that's nice. We're going to go to release and 64. So we're doing a 64-bit game release because we don't want so much debugging info right now to convolute stuff. Because if you build stuff for release 64, I feel like you do all your source and all your libraries and linkers for a release, and then later you try to use the debug version, the debug is gonna error out and say, look, we don't have all the icons to debug this thing you linked. So yada yada yada, just keep it consistent basically. And if you want to know more about it, Google is your friend. There's a lot of details online about the difference between release and debug. Now I feel like I'm over explaining. I'm going to get into it. We're going to add some includes and libraries. Let's go ahead and get a screen going. Excuse the scatterbrainedness. Kind of just winging it here, but I hope it's helpful. We're going to include, well, GLFW3. And of course, it's not going to find it. So we'll go link that real quick. That's really all we're going to need there. Right, so let's go link it. I've already got them built, so all I've got to do is just go get them off of my drive here. Okay, it looks like I have a folder named dev on one of my root drives, and I got GLFW3 here all ready to go. So what I did previously, you can see in the previous videos, basically I built this using CMake and made sure it was released 64 and for Visual Studio 2019. So what we're going to need here is the includes, and we should have an area where we built the library that's going to go in the library. So the includes are going to go in the includes here, and the built libraries are going to go into the libraries here. Let's start with the includes. Alright, so I think what we're going to have to do here is just navigate to this location. So if we right click on it and go to Open Folder in File Explorer, we'll get to the include folder that we made. And we want to go back to our other folder here and just drag, or we'll do a copy. Control C, Control C, Control V, and just copy it over there. And we're all done there. Now we'll go into the build, and we're going to look for the files we built. What we're actually looking for is .lib files. It's got to be in source, yeah. Looks like it builds it into source release, and there it is. So let's copy that sucker, and that should be the one we need. We'll go ahead and paste that in there. And now we've got our include source files and our library files in there. So we can go ahead and close this. We'll stay here at this dev in case we need it. I'll just minimize this one. And now you see they haven't shown up here yet. We just have to hit the refresh button and they will pop right on up. There they are. And you don't have to include them in your project, but what you do have to do is tell your source files where to find all your includes. So the way you do that is you just go to the top level of your project and right click and go to properties. You can also get to that same thing through this project properties, and there's probably other ways too. So you want to go to the properties, and bear with me a second. Let's if you already know this, because we did cover it in the previous videos, I just want to cover everything in one video here. That way nobody gets lost. So we go to the VCC directories here and make sure we're on release in 64. And you want to look for the include directories, and over way to the right there's a little caret. You click it and then click edit, and you'll get some lines here, and you basically just click on the line and then click on these little three dots, and you highlight the folder that is your include folder and hit select, and then you're pretty much done, except you can do the macro thing like I showed in the first or second episode if you're going to be working on this from different computers, the solution dir thing. You can, instead of this whole first section, there's a macro for a solution dir. So that's going to be the same with the libraries here, except we're going to point to the libraries folder. And there we go, and hit OK and OK. And another thing which we're going to go ahead and do is set up the linker for GLFW3. That way it doesn't complain the first time we compile. So we go down to the linker and open the caret and go to input, and you'll see additional dependencies. And you're just going to click on that and once again go to edit, and this time we're going to add the name of that library, glfw3.lib. And it knows where to find it because we told it where the library files were, right in this folder, and now it is also linked. And I also know just from experience that we're going to go ahead and need OpenGL32.lib. So we're going to hit OK on that as well and apply. And now we've got those two main things linked and ready to go for when we program this all up. Now, we want to pop up our first window with GLFW3. It still seems to be complaining about not finding it. That's because I've typed a 3 here when there is no 3. But otherwise, it looks like the header is correct. Don't use the native one. I don't know what the difference is exactly, but it's different. So we'll hit play here and just make sure nothing crashes. Make sure there's no errors. And it looks like it pops up a window. Everything looks fine. No build errors. But we're also not doing anything yet. So what we're going to go ahead and do is just go over to GLFW3 on a Google search and look for the window guide. So if you do that, if you just do a search for the GLFW window guide, you'll find the latest and you'll see some basic starting a window stuff. So we're going to click on window creation here, and it shows us a bit of code. Looks like we're going to need a window. We're going to need to call this create window, and we're also going to need some other stuff. So we'll go ahead and do this create window. And then we need to do a thing where we make our window the current context. I'm going to look for a block of code that has this all included, which should be, I don't know where it's at exactly, somewhere on their website here. Let's look for the documentation, and here we go, right on their first example code. They've got a thing of you setting up the window, initializing it, creating it, terminating it if it fails to create. Otherwise, we're going to make the context current. Then we go into a while loop where we show the window and do all our double buffer stuff. And at the end of our program, of course, we terminate GLFW and return 0. So yeah, that's perfect. That's exactly what we want. We'll go right to here because we got the rest. And we'll go back over here and just paste that in. Let me get rid of this original one here. And this should be enough. See, this GL clear right here is a OpenGL call. So we had to have the OpenGL ready and linked. And everything else here is GLFW3, GLFW3 looks all good. So now what should happen is we should get a window with the resolution 640 by 480 and the title Hello World. And we'll go ahead and hit play here. And there's our little window. Doesn't do anything yet. We're using about 35 megabytes of memory to run our program so far. GLFW3 does handle all the resizing stuff, so you can do the usual stuff with your Windows as your operating system sees fit. And as you can see, the memory changes as it is literally using more pixel space. So now what we want to do here is just make a little thing to render with OpenGL. As you can see with that window, it is a certain size. Now the way OpenGL does this, it translates the space of your window with a 0, 0 in the center, just like a XY graph. And it goes 0.5 to each side. So right in the center is 0, 0, XY 0, 0. And if you go to the left all the way and in the center, you'll be at negative 0.5x. And to the right would be positive 0.5x. And at the top, of course, is the Y, with the positive being up and the negative being down. So it all works on a 1-to-1 scale. All the way across the screen is 1, from top to bottom is 1, and that way 0, 0 just stays in the middle. That's how OpenGL thinks of it. So we can start actually rendering pixels with different colors at any time using those coordinates as the position. That won't be very great for 3D. What you need to do to get it to be 3D is have some kind of viewport, or what people usually call a camera class, but it is literally just the viewport of the screen, and then you warp it with matrix math to make it look like you're in a first-person world or whatever you want to do, and you translate your objects in that space via the viewport, and that's where all the magic happens of rendering cool stuff and getting cool lighting. So that's a very quick explanation of it. But let's go ahead and get a few pixels rendering here, because now the window is working excellent, as you can see. And we have done nothing really but set up our project and just make sure our window pops up in our main loop and just handles all the very basics it needs to handle. Okay, I think we're just going to do this in functions. People often encapsulate this sort of thing into a class, but we are just going to use a header. We'll just call it a new item, header, and we'll call it OpenGL Pixel Loader. Sure, that works for now. That's an awful long name. But in this, we can just build up our functions and then include them in our main so that we don't have to convolute our main too much. So we'll go ahead and include, spell include right, our OpenGL Pixel Loader here. It doesn't have anything in it yet, but that's fine. We will build some stuff. So we're going to do a void load up pixels. I don't know, we'll say load up square. And this is going to do some special stuff where it pushes some points that turn out to be a square to our graphics card. And we're going to also have a unload square. Oh, I spelled square wrong. This will just remove it. This is just going to remove all our square data from the video card if we request it. That way we can clear space for more objects. So that's something you kind of gotta need to know if you're loading up models and stuff, is you want to know how to unload them and actually purge the memory on the card. That's pretty important. And we'll just have I guess just a render method that is just going to draw our said square. And let's see, what are we going to need here? Let me think about this for a minute. I'll probably put another pause right here. Okay, I've just posted or pasted in some stuff for loading up a cube, It's basically a bunch of vertices with positions, normals, and texture coordinates. It's a little overkill at the moment. I could probably get rid of all these. I'm just going to do positions for the moment. So I'm going to get rid of all the extra stuff. And as you can see, it just draws at -5 to +5 boundaries. And I've also noticed that none of these calls seem to be recognized, and the problem there is we don't have our OpenGL context linked. Usually people use something like glue, like glu.h, but there's also glad.h, and we can go ahead and get glad. It's basically another thing that just grabs all the OpenGL context, and what you want to do is just go to Google and look for glad C OpenGL, something like that. Something like this, glad C OpenGL, and you will find this website by david.de, who is an excellent man who has helped a lot of people with this header. And basically this just helps you link to the right version of OpenGL. We're using plain old GL here. We're going to go to the latest version because I have a pretty recent video card and it should support it, and yours probably should too unless you're on a dinosaur. But you can check that by checking the details of your graphics card if you're curious about exactly what version you're on, and I think I went over that in the first or second video, so have a look there if you're not sure. But in general, if you're running new stuff, 4.6 is fine. These ES versions are for mobile stuff, and you see a bunch of extensions, and we basically just want everything. We want the core, so I'm not sure how much this matters, but I'm going to do core. So OpenGL version 4.6 core, not going to pick anything specific. We're going to go ahead and keep this generate loader there, and we'll just click generate. And that will give us a link to a glad.zip. Okay, let's go ahead and download the zip. So we've now opened it, and we can get out of this website. So you need that zip, and you want to just open the zip. And basically what we're going to do is just also put that in our includes and in our library if need be. Let me move that off for a second, and I'm just going to do a open folder in File Explorer to get back to my includes here, and I see GLFW3. So in here, I also want to put in this glad and KHR, which is for Chronos, in here as well. So I think my unzip will do it. No, it looks like it brought the root folder with it, so I'm going to need to do a little correction there because I don't want an include folder within my include folder. That's confusing. So we'll delete that after we get those moved out. And we'll make sure they're in there, looking good. We got glad, and we got that as well. Okay, very excellent. Let's take a look at the source folder and see what we got. We got a glad.c. Now this is needed in your source folder as well. I just happen to have the same name there, so that's neat. Yeah, we're going to go ahead and bring this in. I think it's going to, yeah, put it in our source here. So we'll hit this refresh button now that we've included those, and we'll see a few new things pop up. There's glad. There's the KHR. We're not necessarily going to use this KHR, but I wanted to go ahead and link it just in case it comes in handy. So there's a glad.c. We want to make sure this compiles, so we're going to go ahead and right click it and do an include in project. So whatever folder it's in, doesn't really matter that much. I actually think I'm going to drop it into this include folder here, and I get some error, but it's probably just that Visual Studio hadn't made its correction right away. But it is still included in the project, so it should still build. And now what we do, we just hit save on everything. When we go back to our OpenGL pixel loader and we see that glad is here, we also need to make sure we go into the glad folder. And then yes, glad.h, very good. So now it is linked and it will build, and this should now be pretty happy about these functions to GL since we have the thing that references them all there. So that's all well and good. Now, as you can see here, I have some variables that I copied over that aren't instantiated. I have a VAO and a VBO. Now, one of the things we're going to need is we're going to need to save this VAO because, well, if you're rendering a bunch of different objects, you have to switch to which one you're rendering before calling all your render calls. So what we're going to do here is we're just going to take this cube VAO and we're going to make a global for now. This is not necessarily a good idea. I usually want this encapsulated somewhere of an unsigned int cube VAO, and we'll just set that to 0. Oopsie. If I can type. And we're going to make sure that this is static so that it doesn't change. We just want to make sure there's only one cube VAO. And if you're wondering why our background is black, it's because we're using this GL color buffer bit, and it is probably set to all black by default. So you can actually change this color buffer bit to something else if you want a different colored screen by default. Alright, so now we've got the cube VAO. It seems to be happy about that. And it wants a cube VBO as well. Now this references which array in the VAO. So the VAO is like, it's a stack of VBOs basically. So we'll take this VBO and we'll just instantiate it somewhere. And we'll go ahead and just make it an unsigned int up here. And I guess we can have it be static, that's fine. We just don't want ever more than one of them at the moment. And there we go, now it seems to be happy. So what this is going to do is, of course, we're going to declare an array of floats called vertices, and it's just a bunch of positions. So this is a bunch of points, these are x, y, z. Now, without a viewport, the z doesn't make much sense because it goes away from you. And the same with it being positive doesn't make a whole lot of sense because it just comes towards you. So you need a viewport to really see the difference between those. Let me just comment these out because we're not using them. But basically, these are pointing to a shader typically. So the first array is 0. So we're enabling the very first one, and we just need to tell it that it is this data of the vertices, and we've got everything set up here for it to do its thing. There's one thing that's a little different here because we corrected this. It used to have 8 different points per set of data. Now it only has 3. So this is no longer times 3 floats of width. It's no longer times 8. It's only times 3 floats of width, and it's the very first one, so it's void 0. But this is basically where at in your data. So you basically always want to be using and buffering your data in arrays like this. That way you can calculate where at in memory to send to it. And we'll go ahead and comment out this line. Actually, we'll leave it here just so it will say cube loaded the graphics card. And we'll go ahead and include the IO stream so that message can work. And at the end, we're going to bind vertex array to 0. So it's up to the render call to rebind the right vertex array before rendering. And that's going to look a little something like this. So when we're ready to draw this cube that we loaded up, we bind the VAO, that's the very top level one, and then we enable the attribute array, which is the VBO thing, and it's the very first one, so it's just 0. That's where it indexes in basically. And then we want to draw arrays, and we're going to draw with triangles, and this says 0 to 36 because there are 36. And then when we're all done doing this draw, we want to set the vertex array back to 0 so it doesn't mess up any later calls. So that's how you render. So if we call these functions, it might be enough to work. Let's double check. So we're going to call load up square before we get to this while loop. So we'll do that right here. Load up square. That should push it to the graphics card. And then we're going to call render. Right about before the swap buffer. So we got to do the clear first. Then we do our rendering. And that renders onto the back buffer. So you got to do a swap, and that will bring whatever you last rendered to the screen. So and then it'll pull for events from the keyboard and mouse. That's a GLFW thing. And it'll render these points. Now I think it's a black screen, and I think it's going to be a white cube. Let's see. We're not getting much. Oh, okay. What I need to do here is I need to include GLAD before GLFW3. So that's a little confusing. That's a little obscure. Okay, now I think that will resolve it. Let's go ahead and just do a rebuild. Yes, so you have to include GLAD before GLFW3. One succeeded. We're looking good here, and we'll go ahead and run what we got. And we shouldn't really see too much. Oh, no, we see everything fine. Okay, so this is our first square, or our first cube that we loaded to the graphics card, and it seems to be rendering just fine. Okay, so hopefully I can cut this together in a way that makes sense to everybody, but that little GLAD thing needing to be before GLFW3 really tripped me up for a minute. Basically what happens is you get a default shader that does very basic things only. And there's probably more info about that, but it just colors your pixels white, it looks like, to start out with. So in our main, we've got it all set up. We don't ignore the shader thing. We'll get into that next episode because we will start having to pass in the view matrix to the shader so that it knows how to render our box and do more of a square version. All right, we've got something rendering to the screen, and hopefully this helps you guys out some. And oh, I guess I also did want to show you how to unload the square from the video card when you're done. So let me just find that. I think it is it's one of these. It's like a remove buffer. It's like GL delete buffer, delete buffers, and then I think the size is going to be the same as whatever we started out as, and then it's just going to be that cube. There's a chance I'm doing this slightly wrong, so maybe you can correct me on that if you learn better. But this delete, basically you want to remove the stuff in the buffers. All right, thanks for checking out this episode. Hope you guys were able to get your little square rendering on screen. I'll try to do a new one soon, a new episode soon, and I'll pick up right where I left off. We'll get the viewport going, and we'll start doing some little 3D stuff. I'm trying to figure out the best way to get support on this channel, so anything you do helps a lot. If you're watching this video, thank you very much. If you give it a like, thank you even more.